Viewers, I discussed today how to evaluate a kernel in especially for the short type of question and answer, and this type of questions is very much useful in competitive examinations. Let's watch. The viewer who are watching this video first time, please subscribe the channel and press the bell icon to get all the notification and latest update on my videos. Let's watch. If G be a group of non-zero real number and these numbers and this number is under multiplication, there is a multiplicative group G from 5 to 5 and such that phi of x is 2 to the power x and all x belongs to G, then kernel phi will be number 1 option is 1, second is 2, third is E and fourth is none. Then how to evaluate this type of kernel? How to find it? If we consider phi x equals to 2 to the power x, and we already know that kernel is nothing but this reflections of the identity elements, then how to find this type of identities, the existence of this identity? And if we consider it, this term 2 to the power x, then what will be the final identity element exist in this domain set actually to make it here? That's another identity element in G, and we know simply if we test it that result will be and from this part of images, if it will be E, then it's simple calculation, that's 2 to the power x is equal to E, and if we find its result, which imply this result x will be nothing but log E to the base 2, and if we substitute it, phi of log E to the base 2, that is 2 to the power log 2 base E, that means E. So finally we find E is the identity element belonging to G and it's clear non-zero real. So final result will be kernel will be log E base 2. So first option is correct, second incorrect, third also incorrect, fourth is none. So option D, none, will be the correct answer, and here kernel phi, that will be clearly log E base 2. This will be the kernel phi, so none of this. And if we consider another questions, let Rx denotes the group of all polynomials with real coefficient under addition for any phi x belongs to Rx, and let phi dash x, that is the derivative of fx, f dash x. If we consider Rx denotes this polynomial under, and for any fx belongs to Rx, let f dash x be the derivative of fx, and let phi from Rx to Rx be defined by phi of f, that is f dash, means derivative, simple derivative. Then kernel phi will be set of all constant polynomial. Next is 1 plus x, third option is Rx, fourth option is none of the above. Then how to solve this type of problem? Let's watch. If we observe this type of the polynomial and where 0 is identity, okay, identity element of Rx, it is clear. So for any constant polynomial, if we say any constant polynomial, if we say C, whatever may be, that belonging to Rx, and if we testify it, phi of C, that is a derivative C dash, and C dash means ddx of some constant C, and it is clear 0. So kernel phi will be, it is a set of all constant polynomials, whatever may be, set of all constant polynomials, and so first option, set of all constant polynomial, is correct. and GB are group of real numbers under addition, and phi such that G to G be such that phi x equals to x plus 1 x belongs to G, then kernel phi, what will be our kernel phi? The first option is 0, second is -1, third is 2, fourth is none. Then how to solve it? If we testify it, it's clear homomorphism, no matter for that, and this result phi x equals to x plus 1 x belongs to G. And if we test it, it's a 0 element. Phi additive identity, that means phi x equals to 0 for all x, this x belongs to G, so identity element will be only 0, additive identity element. Then how to find this additive identity? If we are testing it, phi of -1 simply, then it is 1 plus 1, that is 0. So -1 will be the kernel, 0 it is 1, not additive identity, 2 is not possible, so only kernel file is -1. So second option is correct. And in this way we find this kernel of homomorphism, and in all this area we ignore all the cases to test homomorphism, because it is assumed that all homomorphic property exist in when we find this kernel, so we are directly find out the result of kernel and in this questions paper. In this way we end our discussions today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thank you.